This problem is more complex than the inclined plane because now we're going to be dealing with three different vectors. The problem you'll see on your problem set is easier because the angle of the string, I believe it's a spider suspended from its web, the angle here and the angle here in the problem are the same. That means the forces or the tension forces on each part of the string are going to be the same. Here, because the angles are different, the tension is going to be different on each of these cables, T1 and T2. The first part of the problem, it says, what is the force of tension in the cable attached directly to the light? The tension from the cable pulling up and the force due to gravity of the light pulling down. So since the light is 20 kilograms, my weight is going to be 20 times 9.8, which is 196 newtons. That means my tension pulling up, so in the opposite direction, is also going to be 196 newtons, but in the opposite direction. So these two vectors should be equal and opposite. Now, the second part of the problem is where it gets a little tricky. I'm going to redraw it here. So this is 196 newtons, T2, T1. If I know the angle that something makes at the top, I know that this angle will be the same as this one. And 37 is up here, so 37. What I'm going to do with this is I'm going to break this these vectors into an x part of the vector and the y part of the vector. I'm going to do that for both of them. I'm going to make my total vector a little bit darker, just so we know that's the total and it's the hypotenuse. So we know two things. Because this stoplight's not moving, the two opposing horizontal forces need to be equal. And because it's not moving up or down, the total force in the upward direction, the tension from both those cables, has to be equal and opposite to the tension going down, which is 196 newtons. So I can use my trigonometry here. And first, I'm going to just look at these two opposing vertical forces. I know they have to be equal and opposite, but when I use tension 1 and the angle, the component of this is going to be T1 cosine 37, T2 cosine 53. So I know that T1 cosine 37 has to equal T2 cosine 53. So this fact is going to come in handy in just a second. The next thing I'm going to do is I'm going to figure out the vertical components of these. So the vertical components here are going to be using the sine because it's opposite over hypotenuse. And so my vertical components will be T2 sine of 53 and T1 sine of 37. I know that these two added together, and my vectors aren't really proportional here. These two added together is going to equal the 196. So I'm going to write another equation here. T1 sine 37 plus T2 sine 53 equals 196. Well, I have two equations and two unknowns. That means that I need to use both of the equations to figure out what my unknowns are. Again, this is more complicated than the one that's going to be in your problem set because both the tensions will be equal. Here, though, I could say that my T1 is equal to T2 cosine 53 divided by cosine 37. Now, when I'm working on problems, I try not to round my numbers until the very end. So since I know cosine 53 and cosine 37 are going to give me some wacky number with a long decimal, I'm just going to leave them like that. Excuse me. Now, what I need to do next is I need to replace my T1 here with this expression. And I get something that looks rather ugly. It will be T2 cosine 53 divided by cosine 37 times sine of 37 plus T2 sine of 53 equals 196. So that is rather ugly. But if I put these numbers into my calculator, these trig functions, I can get something that comes down to 1.25 T2 equals 196 newtons. So what I did was I calculated that on the calculator, calculated this, and then I had like terms, so I added them together. All right, that gives me T2 equal to 156 newtons. And then I would take that and substitute it back up here. And I get T1 equals 118 newtons. Now, these are the magnitude of the tension, the total magnitude. It's not breaking it down into X and Y components. I could go back and figure out what my X and Y components are, but I don't want to. So my two answers are that T2 is 156 newtons and T1 is 118. And so I could go up here and I could say that T2 is 156 newtons, T1 is 118 newtons, and T3 was 196 newtons. What I did is I wanted to check and see if I had the right answer. So I decided I'd use a vector calculator on the internet. What I did is I put in the magnitudes of my three tensions and the angles. So tension 2 was 156 at the 53 degree angle. Tension 1, if I thought of it in terms of the unit circle, was 118 newtons at 143 degrees. And again, I just did that to put it into this calculator. I wanted to put all my angles in terms of the unit circle, the reference side. And then because tension 3 was pointing straight down, it was 196 newtons at 270 degrees. 270 degrees would be 3/4 of the circle. When I put this all in, the idea here is that I wanted my vectors to all add up to 0. Because if they all add up to 0, that tells me that there is no net force, 0 net force. And indeed, you can see my T2 vector, the red one, the T1 vector, the blue one, and you add the T3 vector, which is going downward, you get right back to 0. So that tells me that my answer is correct.